Hey friends, welcome back to the next video of this topic, the linear programming problem. So we are dealing with the exercise 7.3 in this video. Okay, so without any further delay, let's start the first question. Okay, so let me take, as usual, we take the questions from our exercise. So the first question is, we have to formulate the LPP. Okay, I hope you all have gone through the last video, okay, where I have given you in detail the real-time application of the linear programming problem. Okay, so if you have not seen that video, please go through that, because all the basic concepts we require from that video. Okay, so let's see what this first question is saying. So we have to formulate the LPP in such a way that a manufacturer should have the maximum profit on a sale of A and B. Okay, so this is what our objective is. So first let's read this question and highlight what are the important points in this. A manufacturing firm produces two types of gadgets, A and B. Okay, good, which are first processed in the foundry and then sent to a machine shop. Foundry मतलब क्या पता है आपको? Foundering is nothing but where we do the casting. कास्टिंग मतलब क्या रहता है, एक मोल्ड रहता है एंड वो मोल्ड में कुछ केमिकल्स वगैरह और लिक्विड डालते हैं और उसके बाद एक सॉलिड आइटम बन जाता है वहाँ पे. ओके, सो यू वांट टू हैव द एक्चुअल लुक फॉर दिस फाउंड्री. ओके, सी हियर आई हैव searched for that foundry. Okay, see here, this type of casting is done there. So what we have, this is a mold we have. Okay, and here the liquid is pouring in that. So what happens, after some time this liquid settles in this mold and this outer white part is removed, then you get a solid item. Okay, so this is all about the foundry. And what is a machine shop? Machine shop is nothing but the shop where the molded items will be finished. Okay, जो भी आपके एजेस रहेंगे वो एजेस रफ एजेस रहते हैं. ओके, सो वो एजेस को हम लोग फिनिशिंग करते हैं, उसको स्मूथ बनाते हैं. दिस इज व्हाट वी डू इन द मशीन शॉप. ओके, गुड. सो लेट्स गो बैक टू दिस. सो द नंबर ऑफ मैन आवर्स अवेलेबल. ओके, तो क्या है भाई, गैजेट ए एंड गैजेट बी आर moving from the foundry to the machine shop, and the number of man hours of the labor required in each shop for production A and B, and the number of man hours available for the firm. So all the details are given in this table. Okay, A and B को ये दोनों में से जाना है, foundry से और machine shop से जाना है, but the man hour availability, so each section will require some man hours. Okay, that man hours availability is given. So with the help of this table, see, just by giving this table they have finished half of the part of this solution. Okay, so we just need to finalize the formulate the what we can say is the linear programming. Okay, formulate the LPP. Good. Now let's have the gadgets A and a gadget B. Foundry, for gadget A, under the foundry it requires 10 hours and under the machine shop it requires 5 hours, and for the gadget B it requires 6 hours and 4 hours. Okay, and the total availability hours is 60 hours and 35 hours. Okay, so maximum profit is what you want. The profit on the sale of A is 30 rupees and rupees 20 per unit. So what is our first step? Is step number 1 is what? Identify the x and y variables. Okay, so let x and y be the number of decision variables. Okay, be the number of gadgets A and gadget B. Okay, because I have already told you that the decision variables will get in the last sentence. Okay, where the profit for objective function is given. Okay, objective function is given on the gadgets A and gadgets B. So let's take the x and y be the number of gadgets A and gadget B. Okay, so if the case is like that, then we can directly write this x and y. Now the foundry will be what? Foundry and the machine shops are what? So you will be having for foundry, those are known as the constraints. Okay, For foundry, for gadget A it requires 10 hours and 6 hours for gadget B. Okay, so what constraint you will be having here is you will be have 10x plus 6y, so it should be equals to 60. So maximum available hours is nothing but the 60. So 10x plus 6y should be less than or equals to 60. I hope you are understanding this. So this is what my first constraint is. And for the machine shop you will be having the constraint like this. So it is 5x plus 4y and it should be again less than or equals to 35. Okay, so perfect. So these are what we have, the two constraints. So with that we have the non-negative constraints also, non-negative constraints, so which are nothing but x should be greater than or equals to 0 and y should be greater than or equals to 0. What is your objective function? Objective function is nothing but I want to have the maximum profit by selling the गैजेट ए एंड गैजेट बी. सो एक गैजेट का प्राइस 30 रुपीज़ है, सॉरी प्रॉफिट 30 रुपीज़ एंड गैजेट बी का प्राइस है 20 per units, and you are manufacturing what x and y number of units of A and B. So I will be having 30x plus 20y. This is nothing but my z and I want to make it maximum. So this is what my objective function is. So कैसा लिखेंगे आप इसको? maximize z is equals to 30x plus 20y. So this is what we get the objective function is. So having all these equations give you the full marks, and this is nothing but my formulation of the linear programming problem. Okay, I hope you are okay with this. Okay, perfect. So let's see the next question now. So it says that in a certain breeding firm, okay, see, all the questions are very simple, just we need to focus on the important sentences. What are the decision variables, what are the constraints and all. Now let's see here. In a cattle breeding firm, it is prescribed that a food ration for one animal must contain 14, 22 and 1 unit of nutrients A, B and C respectively. ठीक है, क्या है भाई, एक ब्रीडिंग फॉर्म है, ठीक है, उसमें एक एनिमल को इट मस्ट कंटेन 14, 22 and 1 units of nutrients A, B, C respectively. Okay, two different kinds of fodder are available. Each unit of these two contains the following amount of these three nutrients. Okay, so nutrient A दिया है, B and C, and fodder 1 and 2 they have given. Now tell me, for these three, what is the maximum availability for the nutrients A, B, C? So nutrient A is what? It is 14. Nutrients B is what? It is 22. And nutrient C is what? It is a 1. Okay. Now see how and from where you will get the decision variables. So decision variables will get from the profit sentence. Okay, where they will say that the cost of fodder 1 is rupees 3 per unit. Okay, and that of fodder 2 is rupees 2. Formulate the NPP. मतलब fodder 1 per unit बोला है ना, तो हम लोग क्या बोलेंगे यहाँ पे, let x and y be the number of fodder 1 and fodder 2. Okay, number of fodder 1 and fodder 2. Okay, these are the number of units. Okay, we can say the number of units of fodder 1 and fodder 2. Now see here, so from that what you will get, the maximum profit function you will get as the profit, or the objective function you will get that objective function I will get that it is 3x plus 2y, it is equals to z, and what is your objective is to minimize this cost. This is the cost and my objective is also to minimize. Okay, so this becomes my this becomes my objective function. 3x plus 2y equals to z, and I want to minimize this as possible as I can with the help of these different combinations. Okay, so now let's see the what be the constraints we have. So first constraint is on the nutrition A, then on B, and then on the C. So here you have the X, fodder X, and this is we have the fodder Y. Okay, so the constraints will be having like this. So for nutrition A, nutrition A you will be having 2x plus 1y and must contain 14 bola hai. So you will be having what? It should not be less than 14. Okay, one animal must contain the 14, 22 and 1 unit of nutrition A, B, C. So what you can say is the maximum availability is like this. Maximum availability is what? Like this. So it is 2x plus 1y is greater than or equals to 14 for nutrition A. For nutrition B, you will be having 2x plus 3y which is greater than or equals to 22, and for the nutrition C, I will be having the x plus y which is greater than or equals to 1. So these are what we get the constraints on this minimum cost. And of course the non-negative constraints are what? Non-negative constraints are x is greater than or equals to 0 and y is also positive because they are the number of items of the fodder 1 and fodder 2. Okay, so these 5 equations formulate the LPP. Okay, do not miss anything of this. So the last one is also having the same importance as the first one. So you cannot simply miss this NNC, non-negative constraint. Okay, perfect. So I hope you have understood this. So let's move to the third question. So कहाँ पे भाई थर्ड क्वेश्चन आजा. यस, क्या बोल रहा है थर्ड क्वेश्चन? अ कंपनी मैन्युफैक्चरिंग 2 टाइप्स ऑफ केमिकल्स. ठीक है भाई, 2 टाइप्स करो, 3 टाइप्स करो, नो प्रॉब्लम. A company manufactures 2 types of chemicals A and B. Okay, chemical A and B. Each chemical require 2 types of raw materials P and Q. A table below shows the number of units of P and Q required to manufacture 1 unit of A and 1 unit of B. देखो भाई 1 unit of A and 1 unit of B चा डेटा दिलेला आहे. Okay, 1 unit of A and 1 unit of B का डेटा दिया है. And the total availability of P and Q is also given. Okay, so what is our first step is get the decision variables. So step number 1 is what? Get the decision variables, and from where you will get? I will get that from the objective function. So objective function generally is given in the last sentence. A company gets a profit of rupees 350 and 400 by selling 1 unit of A and 1 unit of B. So what you will write now? Let X and Y be the number of units of A and B. Okay, so what will be your profit function here? So what you want? I want to how many units of chemical A and B should manufacture so that the company get maximum profit. So step number 2 is what? You get the maximum objective function. So my objective function will be what? It is a Z is equals to maximum the profit. So X and Y be the number of units of A and B. Okay, एक यूनिट का प्राइस कितना है भाई? प्रॉफिट कितना है? 350. So it is a what we get the 350x plus second की कितना है? 400 plus 400y. Okay, and what is your objective is to maximize it. Okay, so this is nothing but maximize this Z. This is my objective. Step number 3 is what? You get the constraints. So how you will get the constraints? From the given table. Okay, so you have said that X and Y be the number of units of A and B. So let's write down here X and write down here Y. Okay, and you will go like this now. So P variable के constraints क्या है? P variables, P is for P, what I will have is 3x plus 2y, and it is nothing but the maximum availability. So it should be less than or equals to 120. And for Q, what you will be having is 2x plus 5y. It is again less than or equals to 160. The last is nothing but the non-negative constraints, so which are nothing but x is positive or 0, y is positive or 0, because you cannot leave that simply, because they are the number of units that they cannot be negative. Okay, so I hope you have understood this type of question also. Assume that the entire production of A and B can be sold. Okay, so वो हम लोग यहाँ इसमें cover किया है. Okay, good. So in this exercise we are just formulating the LPP, and in the next exercise we will be getting at what amount of x and y's, what values of x and y will give me the maximum profit. So the values of x and y actually will be going to solve in the next exercise 7.4. Okay, so in this just be perfect in formulating the LPP. Okay, great. Okay, good. So अभी by 3 questions हो गए, and in which they have given the table. Now the real task is we have to get the table by our own. Okay, the 4th question is like this. अरे भाई, okay. Yes. Okay. Now let's highlight the important points. ये क्या बोल रहा है? A printing company prints 2 types of magazine A and magazine B. Okay. Okay. Magazine A and magazine B. The company earns ₹10 and ₹15 on a magazine A and B. See, the profit function is given in the first sentence now. Don't worry. ठीक है, जनरली वो लास्ट में देते हैं, अभी इसमें फर्स्ट में दे रहे हैं. ठीक है, these are the compressed, sorry, okay, earns 10 rupees and 15 rupees on magazine A and B per copy. Okay, these are processed on 3 machines, 1, 2 and 3. Magazine A requires 2 hours on machine 1, 5 hours on machine 2 and 2 hours on machine 3. Magazine B requires 3 hours on machine 1, 2 on machine 2 and 6 on 3. Machine 1, 2, 3 are available for 36, 50 and 60 hours per week. Okay, formulate the LPP to determine weekly production of A and B so that the total profit is maximum. Okay, so your objective function is to make the profit maximum, and the variables you will be having in this, that is A and B. You can get the profit function from here or here. Okay, so let's have the table now first. So what will be the decision variables now? Let x and y profit किस पे मिल रहा है भाई? A and B पे मिल रहा है ना profit. So let x and y be the number of units of A, the number of units of A and B. Okay, जिस पे profit मिल रहा है ना वो decision variables रहेंगे आपके. So x and y be the number of units of A and B. Okay, that is a magazine. Of course, these are the magazines. So let's have the table now. So it is nothing but magazine A, and this is the magazine B. Okay, and the constraints is given on the machine 1, 2, 3. So let's have the machine 1. So this is my machine 1, machine 2, and we have the machine 3. These are the constraints given. Okay, because the maximum A and B require to go through these 3 machines. Okay, then the values you will take like this. Okay, yes. So for machine, magazine A requires 2 hours on machine 1. So ये 2 hours हो गए. 5 hours on 2, 5 on 2, and 2 on 3. See, this is very important. Okay, you should not get confused कि भाई कौन सा नंबर किस रो और कॉलम में लिखना है. रिस्पेक्ट टू रो और कॉलम में जाना चाहिए. मशीन बी रिक्वायर्स 3 on 1, 3, 2 and 6. So it is 3, 2 and 6. What is the maximum availability of machine 1, 2, 3? मैक्सिमम अवेलेबिलिटी कितना है भाई? दिया है ना. So 36, 50 and 60. 36, 50 and 60 is what we have the maximum hours required. Okay, so from this what I can say is that let's have the LPP or the constants. Okay, so let's first get the objective function. So objective function क्या बोल रहा है कि भाई 10 rupees on magazine A and 15 rupees on magazine B profit. Okay, the company earns 10 rupees and 15, so 10 and 15. So objective function will be what now? Objective function Z is equals to 10x plus 15y is maximize. Okay, so इसको maximize करना है आपको. So this is our first step. What is your, okay, first step हो गया अपना. First step is nothing but the decision variables. Second step is what? Get the maximum function. The third step will be write down the constraints. So the constraints will be on the availability of machine 1, 2, 3. So for machine 1, M1, you will be having 2x. So these are the x and y's. So I'll be having 2x plus 3y. Maximum available is 36, so it should be less than or equals to 36. M2 will be 5x plus 2y less than or equals to 50, and M3 will be 2x plus 6y is less than or equals to 60. So this is what we get the constraints. And the final step 4 is what? The non-negative constraints, which is nothing but x is positive or 0 and y is also positive or 0. So in all, this is nothing but the formulation of the given LPP for this given question. Okay, good. So I hope you have understood this also. So let's see the last question of this video, and after that we will stop here. So it says that a manufacturer produces bulbs and tubes. Okay, so क्या बोल रहा है? bulbs and tubes से क्या करना है फिर हमको? Formulate the LPP. Okay, so formulate the LPP. A manufacturer produces bulb and tube. Okay, so let's highlight the points. Bulb and tube. Each of these must be produced through machines 1 and machine 2. A package of bulb require 1 hour work on the machine 1, 1 hour on M1 and 3 hours on M2. ये बल्ब के लिए हो गया. Okay, and the package of tubes requires 2 hours on M1 and 4 hours on M2. Okay, objective function यहाँ पे दिया है. He earns a profit of rupees 13.5 per package of bulb and 55 per package of tubes. Okay, per package बोला. Formulate the LPP to maximize the profit if he operates the machine M1 for at most 10 hours and a day, and machine 2 for at most 12 hours a day. Okay, then formulate the LPP. It's very simple. I hope now by this time you should be able to formulate the table and get the constraints and the objective function. Okay, so step number 1 is what? Get the objective decision variables. Okay, maximum profit किस पे करना है आपको? I want to have the profit on formula maximum profit. Okay, per page, per package बोला है of bulb and per package of bulb tubes. Okay, so you will write like this: let x and y be the number of package of A. You cannot say directly number of tubes and bulbs, because the per package of bulb बोला है. For per package of bulbs and tubes. Okay, yes, this is what we get the step number 1. Now get the step number 2, or before that you just formulate the table. Okay, so you will be having package of bulbs, so pack of bulbs, and the next is pack of tube. Okay, good. So what are the constraints given? Is constraints on the machine 1 and 2. So machine M1 and machine M2. Okay, so now let's have the values now. Package of bulb require 1 on M1 and 3 on N2. So package of bulb 1 on M1 and 3 on bulb 2. Sorry, 3 on M2. A package of tube require 2 on M1 and 4 on M2. So 2 and 4 I will write directly here. Okay, so this is how I get the x and this is y. So maximum availability you can write here. So maximum available क्या बोला है इसने कि 13.5 he earns. So this is not the maximum. So where you will get the maximum is okay यहाँ पे है. So machine M for at most 10 hours and M2 is 12 hours. So it is 10 and it is 12. Okay. Now get the step number 2. So for step number 2 you write the objective function. So objective function is simply write down the profit. क्या क्या है और किस पे profit है. Profit है 13.5. So Z is equals to 13.5 on X plus 55 on Y. So this is I want to have the maximize. Maximize is my objective function. Constraints are what? Step number 3 constraints are what? For M1 constraint is what? It is X plus 2Y. It is less than or equals to 10. At most बोला है मतलब maximum. And for M2 you will be having 3x plus 4y. It is less than or equals to 12. And the step 4 is very simple, which is non-negative constraint. Both should be positive or 0. Okay, so this is how we get the LPP. Good. Okay, so if you write down all these 4 steps with this table, you will get full marks for this. So this is the systematic way to find out the LPP, and of course in the next videos you will be having the values of X and Y. Okay, so the remaining 5 questions we will be seeing in the next video. Thank you.